Welcome all. So, in the previous class we were learning about the power of compounding, and we learned about that how we can calculate the future value of a single amount, and what is the basic difference between the say compound rate of interest and the simple rate of interest, at what rate the money grows, the future value of the money grows when you are say investing it at the compound rate of interest, and at what say pace the investment grows when we are investing at the simple rate of interest. So, this is the some basic difference we could discuss, and we could learn the compounding at the simple rate of interest, right. So, here I would like to say explain it to you now that how you can graphically show what is the difference between these two rates of interest. You can show it something like this, right. Here it is we are taking as the period, and here we are taking as the future value of any amount of any investment. This is the future value, right. So, if you are talking about the simple rate of interest, it goes like this. It increases, but it goes like this, it increases like this, but when you talk about the say compound rate of interest, it goes like this. So, this is the difference in this case. This is the difference you can understand, that initially it grows at a lesser pace, but then later on, because interest on the interest you can understand, right. So, that this growth pace is increasing, and this is going at a simple pace at this period of time. I am showing this that your money is growing at the simple rate of interest is that this rate of interest is going up like this, but in this case it is growing at a very spectacular rate, at a very faster rate, because after some period of time base becomes flatter, base becomes bigger, base becomes flatter, and when the base becomes bigger or flatter, then automatically the growth rate becomes very fast. We invested 1000 rupees for a period of 12 years, but after some period of time, because we are not withdrawing the interest, so at the say you call it as at the say your what do we say here is that at the end of the 10 years or at the end of the 5 years, at the end of the 8 years, your total amount will become very high, because the base of that investment is also becoming bigger, and we are adding further interest on that. So, this is how you can show the difference between the simple rate of interest. This is basically the simple rate of interest, this is a simple interest, right, and this is the compound interest. So, the difference can be seen with the help of this structure, and we have practically also seen this difference, right. Now, I would like to discuss with you one shortcut here, that if you do not want to put into the this all intricacies of the future value interest factor table, or applying the future value say interest factor model, and that all calculations of future the present value into 1 plus r power n, all these things if you do not want to do, then we have got the very simple rule here also, and these are called as the say doubling period rules. We call it as the doubling period rules, or the rules of the thumb of the doubling period, right. If you want to calculate the doubling period of something, then the rules of thumb can be applied here, and how you can apply the rule of thumb here, that for example, the question here is how long would it take to double the amount at a given rate of interest, any amount 1000, 2000, 10,000, 20,000, 100,000 or 1 million rupees, how long would it take to double the amount at a given rate of interest. If you want to find out that period, number of years, that in how many years your amount will be doubling or amount will become double, if you know the say the present value of the investment or the investment which we are going to make, and if you know the rate of interest, then simply by applying this rule of thumb of the doubling period, we cannot get the exact value, means the exact number of years, but we have the approximate number of years that we can reach nearer to the exact value if you calculate the value by applying the future value interest factor table, or you follow the proper say you can call it as mathematical process, right. So, simple rule of thumb given here is, that is the doubling period rule of thumb is the rule of 72, rule of 72. So, whatever the investment we are making, right, and if the rate of interest is given to us, any investment which is invested or any amount with the present value, if it is invested in any avenue of investment and that avenue of investment is giving us 15% rate of interest. So, what you have to do here is you simply divide, this is a standard rule of thumb and this rule is called as the rule of 72. This rule is called as the rule of 72. So, it is the doubling period and you simply divide this 72 by that given rate of interest and you can find out that period by which your amount, your investment will become double. For example, doubling period here when we are calculating, we are taking the rate of interest, assuming the rate of interest is 15%. So, you are dividing 72 by 15%, number of years are coming up as 4.8 years, about 5 years. About 5 years, within a period of 5 years, your investment will become double. Whatever the amount of investment you take, if you know the rate of interest which is going to be paid by that avenue of investment, then we can find out the doubling period. 4.8 will be the number of years, and we have seen means at long back 20 years back or say 25 years back, the rate of interest was something like this 15%, 12% or 13%, but even the banks in India were also paying this kind of the rate of interest, and at that time any investment we were giving to the banks, that was doubling in 5 years period of time. These days it has become more than 10 years, sometime say 12 years also, because the rate of interest has fallen. But if the rate of interest is very high 12%, 13% or sometime 15%, then any amount given to any investment avenue can become double in this period of time. So, rule of 72 says you divide the 72, this say 72 figure of 72 by the given rate of interest, that figure which comes out is the period by which the given amount of investment will become double. And if you want to become more precise, if you become more nearer to the truth, then you can use the another rule, and that rule is called as the rule of 69. That rule is called as the rule of 69. This is a more accurate rule of thumb, is more accurate as compared to the rule of 72, but here you have to add something more in this say formula, that is 0.35 plus 69 divided by the rate of interest. Earlier it was 72, now it is 69 divided by the rate of interest. So, the interest rate is again 15% and doubling period we are calculating is, so we are more precise. Earlier we were saying approximately 4.8 years, but now by applying the rule of 69 we have been able to find out that the rule of doubling, the amount of period of doubling your investment, whatever the amount of investment is, if the rate of interest is 15%, then by applying the rule of 69 our doubling period is again about 5 years and exactly it is 4.95 years, 4.95 years. So, and if you lower down the rate of interest, for example, it is not 15%, for example, it comes down to 10%, then what is happening here? Then the doubling period is increasing, that now in the 7.25 years the total amount of the present investment will become double. If it is 10,000 rupees, after 7.25 years it will become 20,000 rupees, from 10,000 to 20,000 rupees. If we are say having or getting the interest at the rate of 10%. So, two rules are very simple rules are available here in the literature, that rule of 72 and rule of 69. So, if we do not want to go into any kind of intricacies of say applying the future value interest factor and then say applying the future value interest factor model 1 plus r, present value into 1 plus r power n, if we do not want to say indulge into all this kind of the calculations, then simply by these two direct rules or the direct rules of thumb you can calculate the, or we can calculate the say amount by which our investment will become double. This is another important corollary of the time value of money. Now, we will go to the next part, and that next part is the present value of a single amount. What we discussed earlier? We discussed earlier was the future value of a single amount. Now, we will discuss the present value of a single amount, reverse. Earlier we were calculating present investment is going to become how much after 5 years, after 10 years or after 8 years. Now, we are going to learn reverse, that the present value of the future cash flows, a single amount which we are going to get 5 years from now, then what will be the value of that amount currently? If you want to compare it in today's terms, then what is the value currently of that amount which you are going to receive after 5 years or 5 years down the line, right. So, present value of a single amount, and now if you look at this model, this carefully look at this model. If you look at this model, this has become reciprocal of what the model of the future value interest factor. There in the future value interest factor it was, that is the 1 plus r power n, 1 plus r power n, and in this case it has become now 1 divided by 1 plus r power n, right. So, now this has become the discount factor. That was the interest factor, future value interest factor. This is the present value discount factor, you call it as. This is the present value interest factor, or we call it as the present value discount factor. So, for any rate of interest at which we want to discount, and for the number of years for which the after which the cash flow is going to come to us, if you want to convert say any amount coming to us after 5 years, and we know our cost of capital. Now, how you have to find out this discount rate? This should be minimum our cost of capital. This should be our minimum our cost of capital or opportunity cost of capital. So, if I know the discount rate, if I know the amount which I am going to get after that given period of time, and if I know that period also exactly, then I can calculate the present value of that amount. And if somebody says that after 5 years I will pay you 10,000 rupees for any the work I am doing or any investment I am making. So, I should be thinking in today's terms, that after 5 years if I am getting some amount back to me, what is its value today to me, because my efforts are going today, my services I am rendering today, my investment I am making today. So, how much I am getting back after 5 years? Let me discount it and try to find out the present value. So, present value of a single amount, here also if you want to calculate with the help of the model, you can calculate with the help of a model, but simply means as we discussed the table in case of the future value interest factors after calculating the future value of a single amount. Similarly, we have calculated a table of the values, and here these are the discount factors which are available here with us, again the number of years and again the interest rates. Interest rates are normally cost of capital. So, they are available with us, and we have already calculated that, for example, any say cost of capital is 6% and number of years are 2, what is the discount factor? That is 0.89. So, I was discussing with you that, for example, if you go back, then we have seen, I was talking to you that when you talk about the future value interest factor, these values become more than 1, because you are say converting the present value into the future value, and future value will become present value plus interest. So, it should be more than 1, whereas in this case if you talk about that you are converting the future value into present value. So, future value though it will be very high in future, but in present value terms the value of that will be less than 1. What you are going to receive after 5 years, 10,000 rupees, today that is not same is going to be the value of that received 5 years, 10,000 rupees from now is not equal to 5 years. You have to convert that, and it is something less than that, right, because inflation will reduce the value of money or some other factors will play the role. So, this that value of that 10,000 rupees which you are going to receive after 5 years, it is going to be lesser than that. So, this discount factor is becoming always less than 1. So, it means this gives a indication that whatever the investment you are talking about, that will be certainly less than what we are expecting to get after 5 years. So, this is a very clear and simpler way or the method of calculating the say the present value of a single amount or any amount which we are going to receive in future, that present value of that can easily be calculated. Similarly, now we talk about the next part of the present value, and if you talk about the present value of an uneven series, present value of an uneven series. So, if you talk about the present value of an uneven series, because in the basic any investment projects the cash inflow which occurs over a future period of time, that normally remains as the uneven. That cash inflow remains largely, it remains uneven, because if any investment we are making, for example, we invested 50 lakh rupees, 5 million rupees in any project today, any say business project today, after say building up the project and starting the production, at the end of the first year we got some cash flow back. I am not talking about the profits, I am talking about the cash flows back. So, what is that cash flow? Second year the cash flows value may be different as compared to the cash flow we are getting at the end of the first year. Third year the cash flows value will be different what we are getting at the end of the first and the second year. So, all the 5 years or all the 10 years the cash flows values may be different, they are not even in series, they are uneven, they are coming in series, every year we are getting something, but they are coming as uneven cash flows. So, if we get the uneven cash flows and if we want to compare it against some say investment, then we can find out how much is the investment we are making in the current period, which is called as 0 period, and how much cash flows are going to occur to us after the period of 1 year, 2 years, 3 years, 4 years, any foreseeable period. So, you can easily calculate the sum total of that, and then you can find out that whatever the total cash flows we are getting over the next number of the 5, 8 or 10 years, the total discounted value of going to be this much. For example, now we have this model here. Now, how this model applies? This model is basically, if you talk about present value interest factor model, is this, if you want to use it, and this is the sigma of the number of years and time period t 1. If you take this AT is basically the cash flows occurring over the different periods of time, and again discounted by 1 plus r power t the number of years. If you are say discounting it for 1 year, then it will be 1 plus r, if it is for the 2 years, then 1 plus r power 1, or 3 years is so 1 plus r power 2, like that. So, power will keep on increasing as the number of years means in future the cash flow is going to be calculated. So, finally, this way you can say extend this formula, and if you have seen this, finally, the summarized form model of this is the present value of the uneven series can be calculated this. So, again by using this model we already have converted that into some factors, and these factors are already available with us. Those factors from this table, we will not go into long calculations, we will use these factors from the table, and if you use these factors from the table, so you can easily understand that how we can calculate the present value of the uneven series. For example, in this case we have taken how? We have taken the 8 years, 1, 2, 3, 4, 5, 6, 7, 8 years period of time. Cash flows we have taken here is, that is 1000, 2000, 2000, 3000, 3000, 4, 4 and 5000. Now, if you total it up, how much it becomes? It becomes 3 plus 2 5 plus 6 11, then 15, 4 is 15, then it is 19 and it is 24. It is becoming 24,000 rupees. If you calculate this total amount, this becomes is the 24. Again we can check it up, this is 5 plus 4 9 plus 4 13 plus it is 16 19 and 5 24. This total amount if you sum up, it becomes 24,000 rupees. So, somebody may tell that if you make any investment of say 20,000 rupees or not 20,000 rupees, for example, any investment of say 10,000 rupees. If you make an investment of 10,000 rupees today, after 8 years, I will give you, return you the total amount of 24,000 rupees. So, we will be very happy that we are investing 10,000 rupees today, and after 8 years we are going to get back say 24,000 rupees, but we have not to feel happy. As a student of finance, you must be knowing about, we have to convert that future value of the different cash flows amounting to 24,000 rupees into the present value, and that annually we have to discount the annual cash flows. So, if you discount it, we know that this interest factors, present value interest factors are known to us, and here we are discounting it at the rate of 12%. My cost of capital is 12% and n is the number of years. So, here when we calculate this factor is given to us, 1000 multiplied by this value becomes this, 2000 it is, and it is this is a factor, the value becomes this. So, finally, I am not going to get back 24,000 rupees, I am going to get back equivalent to 13,376 of today. I am giving 10,000 today. So, I want that, for example, after 8 years I am going to get back 24,000 rupees as per today's investment, my outflow, cash outflow, how much I am going to get back. For example, if I give today and I have to return back today only, then how much I am going to get back. So, I am going to get back for an investment of 10,000 rupees, I am going to get back 13,376. So, the present value of those cash flows which is going to occur to me over a period of 8 years. is going to be this much. So, this is called as the present value of the future cash flows, and if I calculate the net present value. So, how I have to calculate is the net present value will be 13,376 minus initial investment is 10,000. So, this amount will become how much? 3,376, which is in the literary terms called as the net present value. This is called as the NPV or the net present value. So, we will calculate this net present value, and this analysis we will do while we will talk about the capital budgeting. So, at that time we will discuss all those things, but currently say this is the process how we can calculate the present value of the cash flows, which is coming to us in a series, but the inflows are uneven. That is a series is a uneven series. Now, here we talk about something is the future value of an annuity. Now, we talk about the future value of an annuity, and if you talk about the future value of an annuity, say future value of an annuity is means we confront this kind of problem in our daily lives, in day to day lives also. As a common investor, as a very small level investor, we also confront with this kind of the problems. And future value of an annuity, that for example, I buy any investment say product, and every year I keep on investing 1000 rupee in that product, in that investment fund. So, at the end of 5 years, how much amount for a given rate of interest, how much amount I am going to get back, right. So, it may be possible that I know the interest rate, so I want to know the total amount. I know the investment also. I am making investment. Annuity means same investment you are making every year, you are not changing. That investment is not uneven, but that investment is even. When you are making the even amount of investment, same amount of investment every year, then for a given rate of interest, after a certain number of years, how much that amount will become. So, future value of an annuity. Other way around, the question can be asked is that, for example, I am depositing or anybody is depositing 1000 rupee in any investment fund for a period of 10,000 rupees. 1000 is annuity, means same amount every year, 10,000 rupees for a period of 10 years, and somebody is promising that after a period of 10 years, I will be returning you back 15,000 rupees. It means in total period of 10 years, how much I deposited? 1000 into 10 is the 10,000 rupees, and after 10,000 somebody is promising to return me 15,000 rupees. So, in this question, the question will become as that what is the rate of return? What is the interest rate I am going to get that against 10,000 rupees of annual investment, if I am going to get back 15,000 rupees, how much rate of interest I am going to earn on my annuity, my investment which is in the annuity. So, future value of an annuity can be calculated. So, how we can calculate the future value of annuity? For example, we have kept here is the one problem, that is the say suppose X deposits rupees 1000 annually in a bank for a period of 5 years, and his deposit earns a compound interest at the rate of 10%. What will be the value of this series of deposits, an annuity, at the end of the 5 years, assuming that each deposit occurs at the end of the year? Assuming that each deposit occurs at the end of the year. So, it means suppose X deposits rupees 1000 annually in a bank for a period of 5 years, and his deposits earn a compound interest, the interest is compound at the rate of 10%. What will be the value of this series of deposits, which is an annuity, at the end of the 5 years, assuming that each deposit occurs at the end of the year? Now, how we have to explain it? The amount will become how much? 6,105. This amount will become at the end of the 5 years when compounded annually. Compounding is annually, it is already given to us that when you are talking about the compounding amount, this amount is given to us. This is the compounded annually when we are what will be the value of this series of deposits at the end of 5 years, and the compounding we are doing here in this case is the interest rate at the rate of 10%, and it is a compound rate of interest, right. So, when you talk about this compound rate of interest, how it has been calculated? future value of an annuity. An annuity is a series of productive periodic cash flows. An annuity is a series of the periodic cash flows, payments or receipts. It can be payment also, it can be receipt also, of equal amounts, which we will discuss later on, ordinary or deferred annuity and the annuity due. So, these three kind of the annuities we will discuss later on, but simply you understand at this moment that an annuity is a series of the periodic cash flows, payments and receipts of the equal amounts. So, how we will that amount will become, how much we are investing? We are investing 1000 rupee for a period of how many years? 5 years, and the rate of interest is 10%. So, if you look at this model is given to you, that is the amount, that is the cash flow here, and 1 plus r power n minus 1 divided by r. This is the model. Little different model is here for calculating the future value of an annuity. Earlier what was the model for calculating the future value of a single amount? It was the present value into 1 plus r power n. So, we are doing the same thing, present value is the a into 1 plus r power n, but now we are doing it minus 1 and whole is divided by r, that is the interest rate for calculating the annuity, that is the future value of an annuity. So, what is the number of years? We are getting 1, 2, 3, 4, 5 number of years. How much investment we are making here? 1000 each every 5 year we are making the investment of the 5000 rupees, right. Now, when we have invested first 1000 rupees, after 5 years it is becoming, it's the same invested at the end of the year. It is clearly given in the question, assume that each deposit occurs at the end of the year. It means first 1000 rupees has to be compounded for how many years? 4 years. Second amount has to be compounded for how many years? 3 years. Third amount has to be compounded for how many years? 2 years. This has to be compounded for 1 year, because we invested at the end of the 4th year, and 4th to 5th year only 1 year is there. So, it means only 1 year's compounding. So, when you are doing 1 year's compounding, so what is happening? This 1000 is becoming 1100 rupees, right, and final amount which you gave at the end of the 5th year. So, this amount is 1000 is equal to 1000, because no period has elapsed. So, no interest is due on this. So, finally, if you sum it up, you can calculate the future value of an annuity, that 5000 rupees which we gave. We did not give the total amount in the beginning as 5000 rupees. We gave 1000 rupees every year in the say same amount, that is called as annuity, and at the rate of 10% compound rate of interest, this amount has become 6105 at the end of the 5 years. So, this is the magic of compounding here, and with the help of the future value of annuity process, with the help of this model, which is a very important and interesting model, you can find out that if you keep on depositing in any fund a certain amount every year, at the end of every year, then at the certain number of years at a given rate of interest, and normally the rate of interest are compounded these days, only difference comes up is whether the compounding is annually or the compounding is at the say biannually or quarterly or a monthly or daily, that difference comes up, but normally whatever the return we get these days, they are the compound interest, provided you have not opted for that you will take the interest back every year. So, it means if you take the interest back every year, then it will maybe a say it will be a simple rate of interest, but if you are not taking the interest back at the end of every year, then certainly the total interest will be added back into the principal amount. So, next year the base will be going up. Now, for example, if you look at this base of 1000 rupees at the end of the 5th year, it is becoming 1464. This base of 1000 rupees is becoming 1331, 1210, then it is 1100, and this is same 1000 because it is at the end of the 5th year. So, total amount will become 6105. So, this is how we can calculate the future value of annuity. Please remember all these concepts, because they will be very useful when we will discuss the other advanced concepts in this course, means some other parts of the syllabus, when we will be, or the other parts of the course plan, when we will be discussing the other topics. Everywhere we will be using these terms, future value or present value, future value of a single amount, present value of a single amount, future value of an annuity, present value of uneven series. All these things are useful. So, I am say very carefully discussing all these concepts with you, so that you remain very clear when we start applying these concepts for the say different kind of the business decision making. Now, here are some of the say applications of the say future value of an annuity. Some of the applications of the future value of an annuity which I would like to discuss with you, and we will discuss 4 or 5 applications which are very interesting application and would answer the questions pertaining to your day to day life. Means we all make investment and normally we select some investment products where the investment has to be made say in the even series, and at the end of certain number of years. For example, you talk about that when we take the say insurance policy, and that is not a term policy, but the endowment policy which is basically for the both your say the life saving also plus the money back also, part of the money also comes back. So, every year the amount of premium remains the same. When the amount of premium remains same, you pay at the end of every year or maybe twice a year, whatever it is, and for a certain number of years we take that policy for 20 years, 30 years, and at the end of 30 years they return us some amount. The life of the person also remains insured, but if the person remains safe and nothing wrong untoward happens, then at the end of that period of the insurance that amount comes back. So, there we apply the concept of the future value of an annuity, and there means the part of the amount which is invested in the market for the saving purpose by the insurance company, that amount has to be returned back after means say subtracting their own expenses, administrative expenses and their commission, it has to be returned back. Or anywhere when you say buy, maybe for example you open up an say a recurring deposit. So, if you take the open up an RD account in the bank, it may be possible that every year we decide that I will deposit 10,000 rupees in that say recurring deposit account, and for a period of next 10 years I will keep on depositing 10,000 rupees. So, after the period of 10 years it will become 1 lakh rupees, 100,000 rupees plus interest on that. So, all this kind of the questions we are going to discuss here, and we are going to learn about the applications of the future value of an annuity. So, these are very interesting applications, very interesting say day to day means answer to the day to day problems. So, when I will discuss all these applications, you will find them quite interesting, and you can use them also for answering so many questions which pertain to your daily life. So, all these applications 4 or 5 applications plus some other related concepts of the time value of money I will discuss with you in the next class. Thank you very much.